Hi, Sakshi. Can you hear me, right? Guys, tell me once, am I audible, right, for everyone? Hi, Propti. Yes, Himaraj. Good evening, bro. Can you hear me, right? Yes, that's great. Yes, Himaraj. Can you hear me, right? Yes, that's great, guys. How was the weekend? How do you spend the weekend? Good evening, Yashaswini. Guys, we'll start our topic today's one. Okay, within 2 to 3 minutes. Let them to engage everyone here. Is that chemistry class is over, right? Is that chemistry class is over? Yes. Good. Okay, we'll start our class. Will we start or will we wait for 2 minutes? Okay. And meanwhile, guys, okay, let us discuss the general things. Okay, if everyone will become means minimum 10 members, then we'll start our class. Cool. And meanwhile, if you have any doubt, means let me know. Last class हमने क्या किया था regarding about the capacitor and how the capacitor will be built, how the capacitor will be get charged, and then what we discussed later on. Not about the Friday class, before that Friday class. What will be the potential? How the potential will be increases when the capacitor will be started to charging. Okay, those kind of topics which we covered now. Up in that area, particular area, do you have any doubts? Do you people having any doubts? Sagar, Sakshi, Rapti, Sneha, Yashaswini. I'm asking you only, guys. And those who are in a YouTube, please let me know if you have any doubt means. If not means tell me in a chat box. That is also a good sign, right? Ananya, yes, good afternoon. Good afternoon. Yes. Yes, good evening, Kajasini. Yes, Hemraj, that too great. That too great. Okay, then we'll start our today's session, guys. And moreover, we'll take a quick recap what we discussed in a Friday class, right? In a Friday class, we started with a capacitor with a spherical capacitor, plate capacitors. Actually, we know that parallel plate capacitor, right? दो प्लेट थे, ओके, ये दोनों प्लेट का कैपेसिटेंस we found it. जनरल फॉर्मूला क्या था कैपेसिटेंस का? Q by R, small q by V. By using this one, we find the capacitance of the parallel plate capacitor. C is equal to A epsilon naught divided by D. Correct now? This is for parallel plate. In a similar way, okay, we find the capacitance for this spherical plate capacitor. Correct now? In spherical plate capacitor, we got a capacitance value. Where it is? Here it is. Where? Yeah, here it is. Okay. C is equal to 4 pi epsilon naught R1 R2 divided by R1 minus R2. Right? This is one thing which we completed. And later on, we started the now capacitance over capacitance. Hey, capacity capacitor. Okay, we are measuring that capacitance in terms of energy also, because it will do some work, right? If fan is rotating means that potential will do some work, right? That work we are treating here as an energy, right? What I'm saying, we are treating that as an energy, correct now? RS to store the potential in between these two plates, to store this potential, how much battery has to work? Don't in a both a way you can define, koi problem nahi. How much battery has to work on these two plates to store this charge, to build the potential V across these plates, right? That is also work done. This work done will stored in the form of potential energy, that is also electrostatic potential energy. Okay, electrostatic potential energy. Right, this is the energy which is stored inside the capacitor plates. Now if I want to find out the energy value, means we got in the form of U is equal to half Q square by C. This is what we did. This is a work done actually. Correct? This work done only we set this as an potential energy. Right? By using the value C is equal to Q by V, we changed this one to another format also. What is that? U value will be equals to half C V square in terms of capacitance and as well as voltage. This is in terms of charge and as well as the capacitance. We write this one in terms of potential and as well as the charge only, the third one. U value will be equals to half C V, sorry, QV. Right? These are all the three formats of energy which are stored inside the capacitor plates. Right now, and later on we discuss the energy density. In a simple way, guys, energy density is in nothing but how much energy will be stored in a given volume. We can say this one as an energy per unit volume is called the energy density. We represent this one as an U bar. I told you guys, energy density while writing. Actually, we derived an equation for this energy density also, right? Energy density equation will be come out to be half epsilon naught E square. Don't forget this one. Actually, same equation we'll use for the magnetic field also. There also we'll calculate the magnetic field energy density. Okay, don't forget. This is for electric field. Half epsilon naught E square. And इसका dimension formula भी पता है था मैंने. Dimension while calculating dimension formula, don't go in this part. Okay, try to calculate by using this portion only. SI unit क्या होता है? Joule per meter cube होता है. And solving the dimensional formula, we will get m to the power of 1, L to the power of -1, T to the power of -2. Done? Excellent, excellent. Okay. Do you have any further doubts regarding about these concepts? Tell me in a chat box. Good, Gayan. And those who are watching on YouTube, you have to participate in a chat box. Okay, then if you don't have a doubt, means I have a simple question. Guys, please go through this question and tell me that which is the correct option for this question. When a number of capacitors are connected in series between 2 points, all the capacitor possesses the same. Excellent, Manthan. Good. Good. Good, Yashaswini. Right? Yes, Swastik, right? And then give your best participations, guys, here. Okay. Next. Bharat. We'll look into it. We'll look into it. Next. मैंने बोल दिया था. Yes, Swati, right. Okay. Capacitor plates. मान लो, these are the capacitor plates. They are connected in end to end like this. Okay, if I supply this, means connected this one for the external battery. Okay, external battery. Here current start to move. Current will be same in all the capacitor. Current is same means here charges are moving. Means charges are occupying on the plates of the capacitor will be same. Good evening, Anusha. Okay, it will be same. Means correct option among these 4 will be charge. Clear? Is that clear? Hey. Internet unstable. Look into it. This concept is that energy stored in a series combination of a capacitor. Okay, we got one energy value right now. What is our energy value? We will say like that. energy will be of epsilon naught E square you will, right? This is energy density, sorry. Okay, energy value means U is equal to half C V square, or else you will say energy will be equals to half Q, sorry, Q square by C. Okay, we'll take out one format, any one. Okay, no problem. Now, energy stored in a series combination means I have a, this is for only one capacitor. Okay, if I'm connecting n number of capacitors in series, then what will be the capacitance? What will be the energy in that capacitor we need to calculate? Just imagine for the one capacitor we have the two QS. Okay, if I am connecting like this, n number of, okay, n number of capacitors like this. Okay, till the end, right? We need to calculate now energy, total energy we need to calculate. In series, when it is connected in series actually, okay, capacitance value means equivalent capacitance value can be written as in this format. Equivalent capacitance 1 by C is equal to 1 by C1 plus 1 by C2, 1 by C3. This is C1, this is C2, this is C3, this is C4. Like this, it is there means up to Cn. Going to add all the capacitance in the reciprocal capacitance, right? Yes, bro. Yes. Actually, that's why I turned off my camera. Okay. Now cross check it. Abhi, is my voice correct? जल्दी से बोल दो एक बार. Is that my voice is clear? Okay. Look at here. What I'm explaining is we have to calculate the energy stored in a combination of capacitor. Means n number of capacitor you जोड़ दिए. Okay. एनर्जी क्या होता है? एनर्जी एक कैपेसिटर के लिए हाफ Q square by C होता है. Right now, if I'm taking n number means C equivalent निकलना है. C equivalent किधर से आता है? Reciprocal of this all the, because it is a series combination. Right now if I'm got odd energies, U energy for the capacitor one, which can be written as square, right, divided by this C1. Second, if I'm going to take second one means half Q square by 2. That need to write for n number of capacitor. Correct now, in all the terms, देखो इधर थोड़ा mashup हो गया है, इधर mashup हो गया. Correct now, I will do this one here. Here, this is U1. U2 means half Q square by C2 plus U3 के लिखना है means इधर again हो गया half, just guys, it's not writing. Okay, just bear me a minute. Guys, is my screen is visible, right? Let me know once. Chat box में बोल दो एक बार. Yes, thank you so much. I don't know, suddenly everything will be disappear here. Okay. Okay, we can't do anything here. Okay, so कोई problem नहीं. Yes, the dueling is visible. Yeah. Okay, देखो इधर parallel combination को move हो गया क्या? Done. Sorry for that interruption. Okay, next we'll come across to the third one. Third one means again we have to take q square by c3. Like that, if you are going to write means in all the capacitor charge is same, correct now? 1 by 2 is same, correct now? Only the thing is that c1 c2 c3 are variable here. That's why I will take, apart from capacitance, everything as an common of c q square. Then it will be 1 by c1 plus 1 by c2 plus 1 by c3 up to n number of, we can write this one as 1 by cn, correct ना guys? देखो इधर actually 1 by 2 q square by c1 means u1 होता है, correct ना? Again u2 will be 1 by 2 q square by c2 होता है. Means if I am going to connect all the capacitors in series, means if I want to find out the total energy, what can I do? Can I directly add all the things? Means energy, total energy, if I want, means I will add u1, u2, u3 up to un. Directly add karna energy को. This is a combination. Energy stored in a series combination of a capacitor. Is it clear? Simple है, add करना है. That's it. Clear now? Shall we move ahead? Give your responses. Good Purnima. Good Ashwini. Okay, देखो. The total energy stored in a system, sum of the energy stored in the individual capacitors. Means individual capacitor के अंदर कितना energy store होता है? मान लो इसके अंदर U1 है, means इसके अंदर U2, इसके अंदर U3, इसके अंदर U4. Like that is there, means you want total energy, means you will add all the energies. Total energy will be U1 plus U2 plus U3 plus U4 up to U. Then we'll come across to the parallel combination. Okay, parallel combination में क्या होता है? First देखो, parallel combination में क्या था? दो कैपेसिटर ले लिए थे हम ऐसे. Okay, we connected like this. Correct ना? Either potential will be same. Potential is actually same, but charges are dividing in this case. Correct now? And then total capacitance, if I want to find out, means we'll use this formula. C is equal to C1 plus C2 plus C3, means in parallel combination we'll add the capacitance directly. Right now, again energy के लिए 3 equation था. I will take now this equation of series square. Okay, again if I am going to add the all the energies, means देखो इधर C V square है. मान लो एनर्जी 1 फर्स्ट कैपेसिटर है, इसका एनर्जी U1 है, इसका एनर्जी U2 है, इसका कैपेसिटेंस C1, इसका कैपेसिटेंस C2. देखो V कॉमन है. व्हाट आई विल रूट based on this equation of C1 V square plus of C2 V square plus of C3 V square. Here I can take V square as a common. If I take V square common, means of V square will be the common thing. Then C1 plus C2 plus C3 up to Cn number, again we are adding. Means here also देखो इधर guys, actually U1 value if I am going to write means of C1 V square होता है, and then U2 value if I am writing means of C2 V square होता है. U3 value if I am going to write means of C3 V square हो रहा है. Means it is also a combination of addition of all the energies. Means total energy if you want, means in parallel combination also you can add directly U1 plus U2 plus U3 up to Un. This is the same thing, right? Energy, if you want to find out the total energy of system of capacitor, okay, in दोनों combination में, means in series and parallel combination, what you will do, you will just add U1 plus U2 plus U3 means इंडिविजुअल कैपेसिटर का एनर्जी को ऐड करते हैं, right? That is called the C energy stored in a parallel combination for capacitor. Right? Is that clear? दोनों केस में that's it. Is it clear? Good Punya. Okay, if it is clear means we'll go to the next concept, that is loss of energy on sharing the charges between the two capacitor plates. Okay, just imagine that one capacitor is there. Okay, इसका capacitance था C1. Already it has potential V. मान लो V1 है. ओके, इसके ऊपर चार्जेस है Q1. नाउ कंसीडर अनदर कैपेसिटर, इसका पोटेंशियल है V2. आई डोंट नो हाउ मच पोटेंशियल V2 हैज. ओके, एंड इसका चार्ज है Q2, इसका कैपेसिटेंस है C2. ओके, व्हाट आई विल डू, I don't have a work now, that's why what I will do, two wires. ओके, ये दोनों जोड़ दूंगा मैंने इधर से इधर तक. Just I will connect over these two terminals. Do you know guys what will be happen when I'm going to connect like this? What happens when I connect like this? Is there any idea? Loss of energy. अरे यार, topic है loss of energy. That's why you are saying loss of energy, right, Rajat? No. Yes. Okay, I will agree. First, purely what will be happen? देखो इधर, मान लो V2 potential 10 volt, okay, V1 potential 5 volt. Now tell me, now do participate in the chat box. What will be happen at this situation when I connect these two wires? थिंक करो, थोड़ा आपका दिमाग को काम दे दो. हाँ, राइट यशस्वी. हाँ, yes, now I'm getting a good answers. Hey, charges are there. Net charge will be always zero. Okay, no worries. Okay, potential now V2 के ऊपर बहुत potential है, correct ना? V1 के पास potential नहीं है. That's why potential will be here in this first one. Potential will be increased as second one में potential decrease होता है. Up to that time, current is flowing in a circuit. Once both the potential will be equal, no, both the potential will be equal at after certain time, V1 will be equals to V2 due to continuous flowing of charges, right? In a short interval of time only it will be happen. Now at this time दोनों का potential equal होता है ना, we call this one as an common potential. ओके, कॉमन पोटेंशियल होता है. कब होता है? जब हमको काम नहीं होता है, उस समय दोनों कैपेसिटर का एंड को, टर्मिनल्स को कनेक्टिंग वायर से कनेक्ट करना है. व्हेन वी कनेक्टेड लाइक दैट, कॉमन पोटेंशियल इज अराइव्ड. देन व्हाट इज दिस कॉमन पोटेंशियल? वी कैन से इट्स एन V. वी नीड टू कैलकुलेट दिस V वैल्यू. दैट इज द टॉपिक फर्स्ट वन, राइट? Is it understood, right? Common potential क्या होता है? Yes. Okay. Common potential. देखो इधर. We need to consider two capacitance C1 and C2, and charges Q1, Q2. Potential will be V1, V2, as I told you. The total charge after sharing. Total charges after sharing. Okay. Is equal to total charge before sharing. Charge conserved. You know this law, right? Conservation of charges. Correct ना? Total charge after sharing exactly equal to total charge before sharing होता है. Okay, then total charge after sharing means दोनों के साथ charges होता है. उसके साथ कैपेसिटेंस भी होता है, करेक्ट ना। आफ्टर शेयरिंग मींस आफ्टर शेयरिंग द चार्जेस, आफ्टर शेयरिंग द चार्जेस आई टोल्ड यू दैट क्या हो गया इधर, देखो इधर पोटेंशियल इज वी, कॉमन पोटेंशियल आ गया। एट द टाइम दोनों को कैपेसिटेंस विल बी सेम ही हो रहता है, C1 and C2, it won't change. I told you in that in a very beginning of the class only, capacitance will be do not change with your potential, करेक्ट ना। पहले कितना था, बाद में भी उतना ही होता है, करेक्ट ना। कैपेसिटेंस विल बी सेम, पैरेलल कॉम्बिनेशन मींस C1 plus C2 and then common potential we get V as itself, total charge, charge लिख रहा हूं वो गाइस, C is equal to by V था, करेक्ट ना। चार्ज आई एम राइटिंग चार्ज, चार्ज का इक्वेशन क्या आता है, चार्ज इज इक्वल टू C into V, करेक्ट ना। हियर व्हाट काइंड ऑफ कॉम्बिनेशन इज दिस वन, always it is parallel, like this we are doing means always it is parallel। at the time C का वैल्यू क्या होता है, Q is equal to C1 plus C2 into V। what is this actually, charge after sharing, potential is common, right? it is actually equal to charge value only before sharing, before sharing charge का वैल्यू कितना था, इधर देखो charge means C into V, before charging Q1 charge if I want to write means I will write C1 V1, and then if I want to write Q2 charge means C2 V2, I will write that one here itself, that is C1 V1 plus C2 V2 right now. Now actually our aim is to calculate the value of this common potential, the value find out करना पड़ता है हमको, that's why I will take this term to right hand side। then common potential का value कितना आ गया, देखो common potential value will become to be C1 V1 as itself in the numerator plus C2 V2 divided by, if it is comes to this side means right hand side, it will be comes to denominator, hence it will be C1 plus C2, this is the common potential, clear na? Tell me in a chat box, is that clear or you need one more explanation, one more time explanation, is that clear? yes, good, मत भूल जा इसको, ओके। कॉमन पोटेंशियल इज वेरी इंपॉर्टेंट, व्हाई इट इज इंपॉर्टेंट मींस कुछ काम नहीं था हमको, क्या कर दिया, हम दोनों कैपेसिटर को जोड़ दिए, उस समय आ गया कॉमन पोटेंशियल, क्लियर ना? ओके ओके गुड गुड। उसके बाद गाइस ओके कॉमन पोटेंशियल आ गया, ओके। एक कैपेसिटर था V1 वोल्टेज था, अनदर वन कैपेसिटर था V2 वोल्टेज था, करेक्ट ना। ये V2 वोल्टेज है मींस इसका कैपेसिटेंस, मान लो V2 वोल्टेज है, उसका कैपेसिटेंस C2 था, उसके साथ चार्ज Q2 था, मींस इसके साथ साथ और एक था, दैट इज एनर्जी, आई विल कॉल दैट वन U2 or else okay U2 only I will call। if U2 value is greater as per the given terms, okay, U2 value means potential will be decrease होता है, if potential decrease होता है means energy also क्या होता है, if potential will be come out from the capacitor means what about the energy, is that energy increases or decreases, obviously decrease होता है, correct ना। that is the concept of loss of energy due to sharing the charges between the two capacitors, how much energy will be lost, that one we need to calculate, next thing, correct ना। देखो इधर while calculating this one, total energy before sharing total energy कितना था, ये दोनों कैपेसिटर प्लेट है, ओके, दिस इज कनेक्टेड ऑलरेडी, उसके पास I will call this one as an, where does it print, okay, I will call this one as an U1, okay, कोई प्रॉब्लम नहीं। बिफोर शेयरिंग आई एम टेलिंग दैट आई एम नॉट कनेक्टेड yet, I am not yet connected this one, sorry this one, okay, I'm not yet connected, okay, I'm not yet connected at the time। इसका पोटेंशियल V1 था, इसका पोटेंशियल V2 था, इसका चार्ज Q1, इसका चार्ज Q2 एंड इसका कैपेसिटेंस C1, इसका कैपेसिटेंस C2 था। एट दिस टाइम इसका एनर्जी, ये दोनों का एनर्जी आई एम राइटिंग बिफोर शेयरिंग दोनों को एनर्जी लिख रहा हूं मैंने ऐसे। एनर्जी तो पता है ना, हाफ सी वी स्क्वायर। ओके, फर्स्ट कैपेसिटेंस के लिए एनर्जी क्या होता है, U1 will be equals to half C1 V1 square because it is not yet connected. It is not yet connected. Second, U2 value will be equals to half C2 V2 square. Means now total energy क्या होता है, total energy find out करने के लिए क्या करना है, tell me in a chat box. Total energy calculate करने के लिए क्या करना है, before this concept only I told you. No need to write that formula. Just tell me what we need to do. Yes, that too great. Great. Next. Do participate, guys. If you do participation means I will give chocolates. Online chocolates. What we will do total energy calculate करने के लिए simple है, U1 plus U2 करते हैं, करना. This is what the initial energy before sharing. Yes, I will send you. Okay, and then look at here. Okay, initial energy क्या होता है, this is U1, this is U2. कौन सा flavor? Okay, suggest me one flavor अभी. Okay, as which one you want, that one I will send you. Online है ना? Okay, ये दोनों ऐड करना है. This is initial energy. Okay, what if after the energy will be shared, potential will be same होता है ना? Potential will be same. That time देखो इधर, energy can be written as of C V square, general one. After sharing the energy, okay, capacitance, equivalent capacitance can be written as of C1 plus C2, but potential will be same होता है दोनों के बीच में. At the time circuit के अंदर current नहीं चलता है, means V square आ जाता है, correct ना? This is the final energy. Now we got initial energy and final energy. If I want to find out how much energy is lost, how to find out that energy? This is initial, this is final. How to find out the loss in energy? Yes, good. I'm getting only one answer. Yes, right, Mantan. After a long time, half an hour, this is the first message yours. Okay, we have to take the difference between two energies. Yes, Swati, right. स्वस्तिक कहाँ गए आप? Okay, इन दोनों को बीच में difference लेना. If you take the difference between these two, okay, we will get this answer. Okay, we will get this answer. If you want means I will do prove also. Just okay, let us take. Okay, it is better, right? Mathematical involvement is more in of physics, then only you will get a good ideas. Okay, initial energy क्या था, लिख दो इधर. Initial energy will be equals to half C1 V1 square plus half C2 V2 square. Correct now? Final energy what we got, that is half C1 plus C2 common potential V square. ये दोनों को difference लेना है. Correct ना? ले लो difference. Difference ले कैसे? U initial minus U final I will do. When I do U initial, it will be half C1 V1 square plus half C2 V2 का square minus final value 1 by 2 C1 plus C2 V square. Correct now? But just before this equation, okay, we solve this value, V value, that is a common potential. मैंने बोल दिया था common potential का value का V का value आ गया था हमको. Okay, क्या आ गया था? C1 V1 plus C2 V2 divided by C1 plus C2. Cross check this one. Is it right? The same equation we got, right? Okay, now okay, good. Okay, now we will substitute this v value in this equation. इधर substitute करो. Before that guys, देखो इधर 1/2 दोनों टर्म में है. Take that one as a common. क्यों चाहिए वो? Correct ना? Then u initial minus u final value will be 1/2. Common ले लिया. C1 v1 square plus C2 v2 square minus of इधर C1 plus C2 into v square है. Means C1 v1 plus C2 v2 divided by C1 plus C2 का whole square. Next step, I will do little faster this one. uf minus uf minus 1/2. Either again C1 v1 square plus C2 v2 square minus C1 plus C2. Here I will take like this. C1 v1 plus C2 v2 whole square divided by C1 plus C2 whole square. Here this C1 plus C2, this one power get collapse. ये दोनों मर जाता है. Yes, right. Absolutely right. Okay. Remaining term इधर C1 plus C2 मिलता है ना. इसको मैंने इधर multiply करता हूँ and it will become a total denominator also. C1 plus C2. Right now, and then next step I will expand this term. Okay, term है ना इधर दिख रहा है ना आपको C1 plus V1 plus C2 plus V2 whole square. It is in the format of A plus B whole square. A plus B whole square. Expand this one. Okay, after expansion ui minus uf is equal to 1/2. When I'm multiplying this one here, C1 plus C2. Okay, either C1 V1 square plus C2 V2 square. And then in right hand side we'll get here इसका whole square करना है. Means a square plus b square means a square plus b square plus 2ab. Correct ना? इधर C1 square V1 square. Yes right. Okay. C1 square minus V1 square plus C2 square V2 square and plus 2C1 V1 C2 V2. Correct now? This is the thing which we get, and whole divided by C1 plus C2. This one. I will take this C1 plus C2 outside of the denominator. Simple है ना, इसलिए. Okay. If I took outside, we will get u initial minus u final value will be 1/2 into C1 plus C2. 1/2 into C1 plus C2. Either in numerator, guys. I need to multiply this one to here and as well as so here. Multiply करना है. थोड़ा लंबा हो जाता है. कोई प्रॉब्लम नहीं, करना है. Quickly. देखो, fast में देखो. No need to try. Don't try this one. Okay. You have to know the formula. That's it. Okay. Here on multiplying C1, first term will be C1 square V1 square, and the same thing I'm multiplying to the second thing. At the time I will get C1 C2 V2 square. And then now the term is second one C2. Right now, when I'm multiplying that one to first one, then I will get C1 C2 V1 square. And for the second term, if I'm going to multiply means C2 square V2 square. And coming to the next term here, what other things are there? I will substitute as itself. Okay, C1 square V1 square, and again C2 square. Sorry, C2. Okay, a square is missing, guys. C2 square V2 square plus 2C1 V2 V1 C2 V2. Okay, लंबा हो गया, right? This is too lengthy, right, guys? Okay, कोई problem नहीं. Here I multiplied only for the two things. What about these two things? Clear up to now. देखो इधर, this is minus C1 V1 square. This is plus C1 V1 square. These two cancel. This is minus C2 V2 square. This is plus C2 V2 square. These two are get cancelled. Correct now. Remaining thing, guys, what we'll get here? 1/2 C1 plus C2. Here they go. C1 C2 V2 square plus C1 C2 V1 square. इधर मिला है, बाकी A बचा है, minus 2 times C1 C2 V1 V2. करेक्ट ना? देखो एक बार, करेक्ट है ना? I know this is lengthy one. Is it correct, right? What I did? Don't write this one. Okay. After then you take a screenshot. It is enough. But it is very important for your CBSE. Definitely, I will tell you. Okay. आपका दिमाग बेजा फ्राई हो जाता है when teacher will solve this problem. Sorry, derivation at the classroom. इतना सारा मैथमेटिक्स है ना इसके अंदर, इसलिए. Okay, देखो इधर. Here, all the terms we can take C1, C2 as in common. करेक्ट ना? ओके, मैंने ले लिया कॉमन. ओके, आफ्टर कॉमन लेने के बाद क्या क्या मिलता है देखो एक बार. आई विल राइट ओवर हियर. ओके, देखो इधर. आफ्टर टेकिंग कॉमन दैट वन, हाफ C1 plus C2, okay, into take C1 C2 common. I told you, करेक्ट ना? अरे यार नेटवर्क अनस्टेबल कर. C1 C2 if I'm going to take common means what I will left with that one. देखो इधर V2 square plus V1 square minus 2 इधर V1 V2. Screen is not visible. Is this for everyone? Is that screen is visible, right? What I am doing? Confirm it. Soon. Yes. अभी check कर लो एक बार. Yes, it is visible. Visible. Okay, that too great. Okay, देखो इधर क्या मिला हमको. C1 C2 divided by C1 plus C2 है. इधर देखो इधर V square plus C1 square minus 2 V1 V2. Which is the what format you will going to observe here? Which format it is there? A square plus B square minus 2AB, right? We can simply yes. We can simply write this one as an A minus B whole square, that format. But here this is a B, this is B, this is the term which will become after, that is 0. That's why what I will write here of C1 C2 divided by C1 plus C2 into this one. Okay, we can write this one as an V2 square minus V1 square. This is what the energy means, change in energy we can calculate. Right. Clear now? Simple. We got same answer. C1 C2 divided by 2 C1 plus C2 into V1 minus V2 whole square. Yeah, it's mistake. Yes. Good. For observing the equation, tell me. Okay. Is it okay, right? Is that understood? Everything? Things are clear, right? From each and everyone. Yes, that's it. Okay. If it is understood means, guys, we have a problem. Okay. Problem मेरा काम है, ले लो and try to solve this one. First, I will explain the problem. The potential difference of a condenser. They are saying here condenser. Condenser is nothing but basically, guys, capacitor itself. Okay. Either capacitance will be 6 microfarad and is from 10 to 20 volt. Means 10 volt initially we will take, and it is increase the potential up to 20 volt. Okay. Now they are asking that increasing in energy volume. What is the value of energy? Right. I will give you exactly 2 minutes of time. Okay. Exactly 2 minutes. Okay. Try once and let me know what is the correct answer among these 4 options. You might think like that. Sir actually did one equation for the change in energy. That is also initial minus value. We got like that of C1 C2 divided by C1 plus C2. Okay, and minus V1 whole square. Okay, this equations are derived. Here C1 C2 bhi hai, but in this problem they given only C. Correct now? How to solve this one? Right now you are thinking in the same way. Correct what I'm saying? दिमाग बेदखल हो गया ना? Simple question है, but it is looking like a complex. Yes, I know. Simple है यार. देखो इधर इधर क्या है, थोड़ा गौर के देखो क्या है. C1 C2 divided by C1 plus C2. For two capacitance, we can write this one as an equivalent capacitors. How the right? In the sense, we can write instead of this whole thing, we can write C itself. Okay. When we are writing C itself, this equation can be written as change in internal energy, or energy can be written as of C V2 minus V1 whole square. Right now, of the C means already they given 6 microfarad, means 10 to the power of minus 6 farad. Correct now, into V2 value, it is changed to value of 20 volt. Right now, that's why we have 20 minus 10 whole square. Right, what I'm saying? क्या है देखो, 1 by 2 इधर 6 will be okay, we'll divide here on itself, then it will become 3 into 10 to the power of minus 6 into 20 minus 10 means it will be 10 whole square. 10 whole square nothing but 10 to the power of 2. 10 to the power of 2, it is plus 2. Here minus 6 is there. On solving, how much you will get? 3 into 10 to the power of minus 4. Means correct option among these 4 will be option C. Exactly right. Exactly right. Guys, did you got right how I solve this question? If you have any doubts, means let me know in a chat box once. Quick. Yes, good, Ashish. Good. Okay, good. Next, our question है. Do it for yourself. Take a minute of time and do it. I will explain the things what they given. The amount of work done in increasing the voltage across the plates of a capacitor from 5 volt to 10 volt is W. The work done in increasing it from 10 volt to 15 volt will be. They're asking the work done. We know that work done is nothing but here storing electrostatic potential energy. दोनों same ही है. Correct now? One thing here that this is a capacitor. Okay, to charge this capacitor, initially iska charge is the 5 volt. Okay, to charge this one we are using the external battery. Okay, just मान लो it is charged at the time its potential is increased to 10 volt. 10 volt. To increase this potential, the work will be done by the battery is W. Is W. Correct now? This is the first scenario. Second scenario, what they are saying, the same capacitor which we are connecting over a battery again. Okay, initial voltage either already 10 volt, right? Yes, 10 volt. Okay, after connecting this one, the potential of this capacitor is increased to 15 volt. Means again increase hoga. Now what will be the new work done? We need to find out here. Try kar lo ek bar. Take a minute of time. Yes, right, Purnima. Right. Excellent. Cross check करो यशस्विनी एक बार. Do cross check this one. Try to participate, everyone, guys. guys think करो, इधर potential change हो रहा है means where come from, okay, change in energy होता है ना, वो दिखाता है, correct ना. First scenario, if I'm going to write the first scenario means work done इधर means change in energy. देखो मैं क्या लिखा हूँ इधर, okay, this change in energy, initial energy minus final energy is only just due to the work done by the battery, correct now. This value is written as, we know that equation, right, of C now V2 square minus V2 minus V1 square. Why I wrote C, you know this one, only one capacitor we are using, that's why. Right now, substitute the values. Now देखो इधर वर्क डन कितना होता है 1/2 C. कैपेसिटेंस कितना दिया है, वो दिया है क्या, नहीं दिया, ओके कोई प्रॉब्लम नहीं. C V2 का वैल्यू कितना है 10 वोल्ट फॉर द फर्स्ट सिनेरियो आई एम राइटिंग, माइनस V1 का वैल्यू कितना है 5 वोल्ट होल स्क्वायर, देन वर्क डन विल बी इक्वल्स टू 1/2. Yeah, right, I agreed, okay. C into 10 minus 5 means 5 होता है, that means 25. I will call this equation number 1. Second scenario के लिए similarly you have to write, okay. I will write this time I will write as an new means work done dash. It's a new work done we need to calculate for here. It will be again half C, again here V2 value कितना होता है 15 वोल्ट. सेकंड सिनेरियो देखो, माइनस इनिशियल वोल्टेज विल बी 10 वोल्ट, will be half E 15 minus 10 5 5 का स्क्वायर कितना होता है, is it right what I'm writing here? Yeah, correct. Okay, again 25 whole square. Yes. Up to this point is understood, right, for everyone? Okay, done. Now I will call this equation number 2. This is done. Right now, just do solve this 2 equation by dividing. Okay, divide kar lo W dash by W. Okay, you will get answer nearly 1.67. Okay, and this just cross multiply this one to here, then new work done you will get 1.67 times the work done. Okay, just do this one. Okay, we'll cover one more small topic, that's why. Is it clear? Just solve these 2 steps. Okay, we'll move on. No, cross check it once, cross check करो यशस्विनी, कोई प्रॉब्लम नहीं. Okay, yes, take this one as an homework question, guys. Okay, this is the same way, but it is depending upon the resistance value, means you need to know the energy value here. Okay, कैपेसिटर दे दिया है, वोल्टेज दिया है प्लेट का, you need to calculate the value of energy. Notes I will upload this notes. Okay, try to calculate this. कैपेसिटर के बीच में we are going to introduce one dielectric medium. Dielectric medium क्या होता है? It's an initially non-conducting medium. Basically we can say insulator. Insulators are not conducting the electricity, correct now? But here dielectrics are without conducting the electricity, they will give the electric effect from one end to another end. Okay, we'll discuss more about this one in a current electricity. No worries. Just before that, dielectric means it's an, I told you that it's an insulator, non-conducting medium. Non-conducting medium means बनाता है उसको बता रहा है. Here few people might be know know about this one in a chemistry, polar molecules and as well as in non-polar molecules. Correct? Polar molecules क्या होता है? देखो इधर, a molecule in which the center of positive charge does not coincide with the center of negative charge are called the polar molecules. Means one atom, if you go to inside positive charge भी होता है, negative charge भी होता है. Right now, the centers are not at coincidence. That kind of molecule we call as an polar molecule. Right now, you might be observing H2O, an example. It's not actually symmetry, right? It doesn't have any. Correct. And then best examples like HCl, H2O, NH3, CO2, alcohol, like this. Okay, I'm not going to in deep about this one. Okay, right? And then electric effect. Effect of electric field on polar molecules is effect. नहीं हो गया कोई प्रॉब्लम. Let me know in a chat box once. We'll go fast. Am I audible, right? Yes. देखो इलेक्ट्रिक इफेक्ट कैसे है कैलकुलेट करना है. मींस we know capacitor. Okay, whether it is one plate is capacitor is charge means one side of a capacitor we got positive charges, another side negative charges. Even one charge will be developed over here means electric field will be developed from positive charge to negative charge in this way. Correct? Now we need to analyze this one in a electric field. देखो polar molecules कैसे होता है. Like this in a material dielectric medium means in all the material like this positive charge negative charge separate होता है. The center of charges. Correct now? And their dipole momentum. Guys, you know dipole momentum, right? There are two charges, opposite sign charges separated by a small distance. That is dipole. The dipole momentum देखो हर एक molecule का different है. Correct now? Different dipole momentum है. Direction. Correct? Right? What I'm saying? Yes. Like this, if I'm consider entire medium, okay, the dielectric medium is actually randomly oriented in random direction. That's why here electric field value will be 0 होता है the polar molecule के अंदर. Okay, देखो इधर. And then again if I'm going to calculate the dipole momentum value becomes 0. And then if I'm going, this is actually without any electric field. Electric field नहीं है इसके अंदर. Okay, if I'm applying any external electric field, okay, purely like this, I said if I'm applying an electric field over here means okay, all the dipole momentum are start to oriented in a one direction. Unidirection means alag direction था. Now they are almost all tending to align in a single direction. Okay, like this they will try to align in a entire body. At this time actually they will carry the electric effect from one end to another end. Okay, one end to another end they will carry the electric effect. Is that clear, right? Is that clear? Let me know in a chat box. This is enough for today's class, guys. Tomorrow I will continue this one along with the introduction of the capacitors with a dielectric medium. Is that okay? How was the class? How you feel? Definitely. One day definitely I will do. Okay then. Guys, okay. We'll see you in a tomorrow class. Until then, take care. No. Teachers never cheat anyone. Okay? Take care. Bye-bye. Meanwhile, if you have any doubt, please stay in a call and you can ask any doubts. Okay then, fine.